Good afternoon, and a warm welcome to the launch of the LUMI AI Factory. Whether you're joining us in person or online, we are honored to have you here for this very special occasion, marking a major step forward for accelerating AI-driven innovation in Finland and across Europe. To start things off, it is my pleasure to introduce our first speaker, Dr. Pekka Manninen, the director of LUMI AI Factory, to give the vision for the initiative. Pekka, please.
Good afternoon. It's a great pleasure to be here. Many thanks for coming. We have a full house, 200 people here on site, 280 people online, so it clearly it draws attention. But now, the good question, I think many of you are pondering, what is a LUMI AI Factory? And today we try to explain it. So we start with introducing the AI Factory, what it's about. So, well, what it's about, and then go a bit deeper in the kind of a service offering of the LUMI AI Factory. Then we have a session on so what is it good for? So how do we use supercomputers? What are the kind of use cases for AI and supercomputing? So we're gonna have three our use case talks, and then comment by Peter Sarlin. And then the last session will have kind of like a more political high-level comments by Kimmo Koski, our managing director, as well as Marilena Talvitie, the Minister of Science and Culture in Finland. And after this, we would like to invite you to for a little bit of a networking event. So there will be something we call virtual posters and demo sessions on different kind of like LUMI use cases, and well, we're gonna go through them later on. And then, of course, networking and some drinks. But without further ado, let me present what LUMI AI Factory is about. And starting from the concept of the AI factories. So this kind of dates back to the State of the Union speech by President von der Leyen in early 24, that European Commission wanted to really boost artificial intelligence innovation in Europe, where the public sector, so research, where Europe is good at, would collaborate with enterprises, startups, SMEs in the development of AI and its related business. And this is becoming reality in a rapid phase. So there has been already 2 series of competitive calls for hosting something called AI factories. So the first wave introduced 7 AI factories in Europe, and the next wave introduced 6 more. And what Commission means with an AI factory is a kind of like a three-way like a platform where extreme scale compute, access to data, and competence comes together for development of trustworthy AI. And each of these AI factories presented here, they are kind of like a one-stop shop of services for enterprises and academic research for well, AI and also other competencies in scientific computing and modeling. And with an idea that each of these would have a kind of a local flavor, so they have a focus on certain AI ecosystems and communities, and kind of are aligned with the national AI strategies. So our AI factory, LUMI, is the biggest of these AI factories so far in terms of budget, and also I would say centers or like partners involved. And what we want to do is to create a comprehensive service infrastructure what comes to artificial intelligence. We are going to build a successor supercomputer for LUMI, kind of an AI-optimized supercomputer, we call it. But at the same time, we are running services on top of the current LUMI supercomputer. So meaning that we can start the work of AI Factory today. And at the end of the, well, not the end of the project, but sort of like during the project, we will really make a trailblazing computing environment here in Finland, together with the service center and all the competence building activities. And at those I will open up a bit more. So LUMI AI Factory is a kind of 3 pillars here. So it's going to be the new successor system of LUMI. We call it LUMI AI. It is a big service center that we're going to introduce a bit better in a moment. And we also want to develop technology for AI, and that's why we have an experimental platform there. So we firmly believe that quantum computing is already a technology that can boost artificial intelligence on this time frame. So it's gonna feature its own quantum computing platform. So this LUMI AI Factory is led by Finland and CSC, the Center for Scientific Computing in Finland, or our IT Center for Science, with participation from Czech Republic, Denmark, Estonia, Norway, and Poland. And in Finland, it's not only CSC, but also Aalto University and University of Helsinki, as well as the AI Finland are partners in this initiative. And like I said, it's the biggest of these announced AI factories so far, with over 612 million euro budget, out of which half will come from the European Union and the rest from the consortium, with Finland having a biggest share of 250 million euro. And this is one of the biggest of these investments by the current government to the Finnish RD investments that target to reach the 4% of the GDP going to RDI. So it is the largest public computing infrastructure investment in Europe so far, and it is the largest of these AI factories. So I think we have a very big mandate to do something completely new. And not only that, so it's not about hardware, but it's very much about talent and competence. So it is also a big investment in how we build together sort of like a next generation of needed skills in Finland and within our consortium. The timeline goes so that we really going to get our sleeves rolled today. So starting today, companies can access the AI Factory services. Of course, it takes us some time to ramp it up properly, but we can start really providing the envisioned services on top of the current LUMI system, so which is a supercomputer up and running in Kajaani, while we are basically building the next gen system we call LUMI AI, and which is then due somewhere in the spring of 27. The experimental platform will also be constructed at the same time, being available together with the new supercomputer. So the services. So what does a AI Factory offer? So, well, first of all, of course, computing capacity. So basically the computing infrastructure, what development of AI innovations will need. So it will be there by available through the AI Factory. It will also, of course, AI without data is sort of like a not really working out. So we are really investing on providing a data infrastructure where the users can manage their data, bring in data sets, use it for training, and of course providing created data sets and data repositories as a service. It is very much about also support. So it is none of the cases are very sort of like obvious. So data is always difficult. So we have a lot of investments in how do we support the usage of and bringing in data and then using it for AI training. But like I said, it is very much about competencies. So it is about training, increasing the AI capacities in Finland, in the Finnish enterprises, together with our academic partners. It is also AI Factories in a kind of also a place, so we will have a co-working spaces in the other university campus so that we can really bring together or like have this kind of meeting points related to the AI Factory. And one important thing is that we really want to have a fingerprint on what is the sort of a capability of Finnish enterprises, not only companies that are kind of in the working with researching AI or making AI products, but actually companies or more even companies that core business something else, how they can basically deploy artificial intelligence to increase value for their business. And then, of course, the sort of like a development of competencies as a kind of a countrywide or in the European level as well. So, but like I said, all the AI factories they serve pretty much the whole Europe. They serve the LUMI AI Factory serves Finnish businesses. It serves the European businesses, but we still have a couple of these kind of spearheads that drive the service development as well as our infrastructure development. So we chose to have a sharpest focus on manufacturing industries, health and life sciences, and communication technology. And these kind of give us different drivers what the infrastructure and the service portfolio need to support. But LUMI AI Factory and LUMI AI is not only about enterprise use. It is still a strong instrument for basic research. So it is our next generation tier 0 supercomputer. So that's why the AI for science and simulation is still a critical asset, but it's kind of a cross-cutting over these focus areas. Also, we want to make our processes so agile that basically we are actually a useful resource for startups. So it is don't need to wait for months in order to get an access, but it's sort of like we can be agile enough for anything related to our services or resources. Then a few words on the upcoming supercomputer. So this is something that is very much still in planning. So even the procurement process hasn't been started yet. So like I said, we target the spring of 27 out of this. But of course, we have something on our whiteboards on what we want to build. So LUMI AI, so it's a new supercomputer installed at Kajaani. We have a 540 million euro TCO budget for it. So it is on the same level as the current number one in the world, which is the El Capitan in the US. It's going to be a heavily GPU accelerated system, but it's not an AI system only. We want to support simulation workloads there, so traditional HPC as well. It's going to have, of course, normal processors, CPUs there, because AI is not only about training, but also very much on the data preparation and things like this. It's going to have our quantum computer and something we call a user access cluster there. The storage system is also a lot of innovation. We talk about parallel file systems, some special breed of storage, and then the kind of like a data management infrastructure, but also minding that machine learning AI need kind of like be basically connected to the outside world all the time. So the connectivity to the data repositories everywhere on the planet is a crucial resource or like a capability. But the main novelty comes from that only part of the system is kind of looks like a current day supercomputer. So it's only part of it. We kind of carve it out there dynamically. Have resources for running inference services, models, this kind of like model serving, different prototyping, like an interactive style working. And there's a possibility where we can really give one research group and set of resources for extended period of time to train a new language model, train a new AI as a service product, whatever. And the one part of it is that we haven't really made big fuss yet, but one important thing about the new infrastructure is that we are also building one of the world-leading quantum computer platforms together with this system, because we do believe that on this time frame, quantum computing can give already quantum advantage for algorithms like quantum machine learning. So we do think that this is not just a prototype platform anymore, but something that actually can bring tangible benefits for the throughput of the users. But we basically want to set up a world-leading platform for high-performance computing, AI, and quantum computing to serve Finland and the rest of Europe. Like I said, we do believe that we can provide a quantum advantage already on this time. And anyway, it's going to be an acceleration of adopting of quantum computing and developing of quantum computing hardware. And anyway, because Europe is strong in the academic research when it comes to quantum computing, it is just like we basically just also want to boost this research and basic research even further. And our roadmap looks like something that we're gonna deploy one system together with the LUMI AI comes online, install a new wave of the same technology, and then even upgrade the one system later on. So there will be kind of 3 waves of it. And it's not out of question, as the qubit count seems to be increasing at the moment very rapidly. It's not out of question of reaching 1,000 qubit system at the time of the quantum computing tree there. So to wrap it up, it's time to launch LUMI AI Factory. So this is a very big step for serving research, development, innovation here in Finland and in Europe. So I'm really happy and proud that our government decided to go heavy in this investment, and then that the European Commission believed in us to be one of the hosting sites here. So the LUMI AI platform, together with LUMI IQ, will be the most advanced, perhaps the most powerful supercomputer in the world at the time of its arrival. And like I said, not only infrastructure, but it's also very much about these competencies around it, which we're gonna hear next. So that's something that we're gonna go on the next level, what we have ever offered as something kind of a user support, but it's much more than that. So like I said, largest public investment in artificial intelligence in Finland and in reality also in Europe. So join me for having an, I don't know, applause for the LUMI AI Factory, and wish us good luck. Let's do with questions so that we take Alex's talk right away. Yeah.
So the idea was that we'll have Aleksi Kallio deliver his presentation first, and then we'll take the audience questions. So now I'd like to introduce Aleksi Kallio, the LUMI AI Factory Service Center Director, and he's going to talk about the service portfolio. Aleksi, please.
Thank you. So we just heard the applause for the LUMI AI Factory, and now comes the everyday life. So LUMI AI Service Center, which is already okay. Oops, I'm somewhere else in the slides. So which is already now operational, has been several weeks by now. So I'll start to kind of lay the foundation with this article from McKinsey Global Institute. It came out last autumn when we were preparing the kind of funding application for for this AI Factory. And the reason I bring it up is that it nicely supports what we are doing. And to be brutally honest, we didn't have any time for reading reports when we were doing the funding application, but instead we're just madly working on it. And afterwards found out, okay, nice, this is actually what we were doing. So what they bring up, Europe needs to invest on supercomputing capacity. Well, that is obviously here. Then building talent and retaining talent is important. That's also something that we are going to do. Then working on kind of localized AI, localized generative AI that takes into account languages, culture, operating culture, and so on is important. It's also, of course, something that we are going to support. And then finally, most important, running a kind of full transformation of research, development, and innovation with AI. And that is where kind of we especially come in. So in this report and many other reports, the kind of the idea is that Europe has potential, great research, good business, great, or depending on kind of the fields. So some fields are lacking and some fields are very strong. So there's kind of potential, but it needs to be somehow, there are barriers that need to be fixed. And here the idea with the services is that, okay, we look into places where kind of this kind of organization like supercomputing center, service center around it, where we can really kind of help and unlock something that is kind of already there but needs some push. And this is the common thread for all the services that I'm going to now walk through in a bit more detail in 10 minutes. So it is still going to be scratching the surface, but at least a little bit more detailed. And AI factories are basically three things: compute, data, talent. And we will start from the end, so from talent. And for that, of course, training is important. And especially if you kind of realize that with AI hype, AI boom, skill sets have kind of become obsolete overnight. So there is a suddenly big training need and big kind of barrier of entry into modern research development and innovation. So to fix this, of course, LUMI AI Factory will work closely together with AI centers, like, for example, the Finnish universities, Finnish Center for Artificial Intelligence, and so on. So kind of bringing the latest skills, the latest technology, and co-create the training portfolio. And then also, there's a lot of training around already. You can find it from the internet. But the idea is that what we provide is a kind of structured training path. So we will answer the question that what should you know? And we have our own resources, but then of course also linked to other resources so that it's easy for our users in companies and in universities and so on to get the latest skills. And then finally, this is not like one size fits all, but tailoring is important part of the activity. So usually training is much more kind of digestible when it is presented in your domain using your language. So that's also something that we are going to do. Then, very importantly, we are going to have a strong focus on company use cases because that's what AI factories really look into. And here the idea is that first of all, we have to remove the friction for companies to get started. So provide starter packs. This is what you can get easily. This is how you can get started in the environment and do your AI workloads. And then also helping with this kind of feasibility analysis. So starting already early, okay, we have a vague idea of what we could do in an AI factory. So would this work out? And then we can kind of help that, okay, let's develop the idea. This you could do here, but this is a problem. So let's work on this. And it's important that we are not alone. So we will kind of weave this into existing networks and ecosystems so that you don't have to come to the AI factory always, but we will also come to you. We will come to the ecosystems and make AI factory kind of natural part of the different environments that require this kind of assistance. And kind of the idea is that for AI adoption, that we can offer this kind of time-limited interventions. So to step up the level of your AI activity, because of course we cannot be helping everyone with a lot of resources all the time, but instead like that our bigger investment would come in time-limited way, and then of course all users would have the long-term access to the system, the platform, the support services, training, and so on. And of course, we will also help in getting large resources. So it can be done through the self-service interfaces, but we are also there to help, and also, if needed, help in getting resources from other AI factories. And then finally, as mentioned, AI Factory will also exist physically, like the service side. So we are setting up a co-working hub and a kind of campus space for co-working, running hackathons, doing workshops, and so on. The main hub will be in Otaniemi area, and then it will be supported by satellite hubs elsewhere in Finland and in our consortium countries, maybe even multiple in single country. And the idea is that they will be running hackathons, challenges, accelerators, but also importantly supporting when someone else is doing hackathons or running on startup accelerator. We are very happy to kind of do our small little part of that. Some example company use cases from LUMI, quite recent ones, and this is here to kind of say that okay, we are not building this from nothing. There's already several years of effort on kind of making the environment company friendly and getting the company use cases in, and you can hear from these on the poster session, and there will be also presentations later on. Next, the compute side of things. So, of course, computing capacity never seen before, as you heard Pekka say, that this is really scale that has not been seen before in Finland or in Europe. Globally leading platform, which means massive GPU capacity for the AI model training activities, then of course all the storage that is needed for that, and importantly it will be delivered well as a shared capacity when possible, but also you can get kind of your dedicated slices out of the system, meaning that when you are working on a demanding AI workload, kind of you can be guaranteed that you will have certain capacity all the time as needed. But it's not only training new AI models. We have identified that actually the other side of the story, so AI inference, serving existing AI models, is becoming more and more important. It's actually, you might even say that almost equally important nowadays. And for that we are also developing services, actually already have a service running in our environment. And the idea is that of course then we would move on to populate it with large collection of models, meaning that pretty much any relevant open model that you might have is available there already. And that would of course make it quite easy to follow the development of open models and then also build workflows that really depend on these models. And these environments, like we will allow within the system to have kind of customizable environments, kind of virtual clusters, so that you can also have good control over the software stack, and we can cater for, so to say, more exotic use cases. And as usual nowadays, API-based access is important, and there's kind of recipes for automation and integrating to public clouds. So like how do you move on from your research, development, innovation into production and commercial use? And finally, as mentioned, important part of the whole system is the quantum computing capacity, and that will be, of course, also integrated in the computing environment. Then, there's not only capacity, but there's lots of people helping you use that capacity. So there's expert support helping our users from getting started, basically, having always a smiling face, I can promise. but you might not see the face because it's mostly virtual, but anyhow, smiling while typing. But that doesn't start from getting started and like the very basics, but we go deep into AI method support on different kind of application areas of AI, and then also scalability, which is kind of no-brainer here. We have a very large system, so we need to be able to help you use it effectively. But in addition to human support, we also put effort into removing the human completely. So self-service is important, so that you can very quickly get started and you don't need to kind of depend on us to do anything. Self-service, thorough documentation, of course, and then also AI assistance that will help you also when our support is sleeping. And then finally, machine learning operations is kind of the thing that makes everything click. So even though innovation is kind of about creativity, then comes to real life. So you need also have the operations, and we will have a supported machine learning operations environment and recipes also for the typical things that you would do. And as mentioned, we are building now on top of existing LUMI systems, so there are services already running with AI Factory kind of twist today, and there will be a demo on the poster session, so how you can run AI workloads on LUMI, some example of some model training here. We also have first online course up and running, and actually also had a physical course already earlier. So this side of things is already moving forward. And then the final component in this whole is data. And in a way, the idea is that with AI Factory, okay, it's a supercomputing system, but we make data as important as computing. And the reason is obvious, because you know that AI is built on data. And that's also where we kind of see that we have the potential to unlock things, because here there's great barriers between potentially big opportunities. So Europe is full of good data sources that are not available right now due to regulation or due to their size or some other reasons. So here we will tackle that. So of course, first of all, we provide a kind of nice environment for working with data. We also provide kind of data sets as a service, meaning that we put a lot of effort into some high-value data sets. And high value means that they are somehow not available otherwise, so not something you can just download from internet, but data that is very large, and for that reason not available, or has access conditions, like it's sensitive or just confidential, or it's someone's business. So here we try to enable as many new data sets as possible. And of course, we need to have good services for working with sensitive data and building kind of access authorization mechanisms that you can have some data sets that are open in a very, very limited way for AI use. And finally, as mentioned, we will connect to outside world strongly, connect to data spaces and important data repositories, and also kind of be an active partner in the data space business in totality. And also, as the computing side, the data side as well is supported by our human effort. So we have a data team that is doing the everyday work to get data in, so sourcing new data sources, having the negotiations on the kind of the conditions that data can be used, curating data when needed, and whatever needs to be done to get data available. And then, of course, also helping users in kind of the necessities, so ranking your own data sets, how to get your data in right format, do the data engineering, and so on. And finally, as a kind of case, also supporting kind of data streams coming in the supercomputer, building infrastructure for that is also important, because as mentioned, we are looking into use cases such as telecommunications, and this is now really kind of covering the whole computing continuum from the supercomputer to the small sensors and everything in between. Some examples of unique data sets. There's also more in the poster session. So and we will actually hear more also later. So Open Web Search is a European open web index that is very large walkthrough of the internet, of everything there goes, and will be made available here. Then Destination Earth is a digital twin of the Earth. Lot of measurement data goes in, lot of simulation data is produced, and we will hear about that in a later presentation. And then finally, third example, big picture central repository of digital pathology slides to boost the development of artificial intelligence. So this is one example of the many kind of health-related activities we are involved in. And here we see great potential, because right now getting access to health data is extremely hard, especially in a supercomputing environment. Like usually the environments for that data are very limited and don't allow you to do AI development in the kind of the modern sense. And we see that if we can break that barrier, then this will result in quite a lot of impact and value created. But then comes the large question, big question. Okay, sounds good. So where I can sign in and get access. So how are they offered? The basic idea, of course, is that this is now environment for research, development, and innovation. In some kind of corner cases can be used for a production use also, but this idea is that we are aiming at RDI use. And the basic principle is that for these use cases, services are free of charge for startup companies and SME companies, for academic research, and then for public sector use. And for large companies, it's fee-based, so basically it needs to be kind of market priced. And how this will be implemented in practice is that, of course, we are running today, so there are LUMI access rules. If you want to use our services tomorrow, then it's possible following the current access rules. But Euro HPC joint undertaking is updating, kind of creating new access policies that are aimed to support AI innovation more strongly. And we will be, of course, adopting these when they are accepted. So the current policy will kind of develop and also make it kind of easier to do AI innovation on the platform. And for large computing resources, the idea is that they are available through access calls with very kind of quick processing times, depending on the call, from day to some days or more for the very large resources. And most of the calls have certain level of kind of requirement for certain level of opening of results. And this is a bit mystical kind of condition, because it depends on the use case. But the idea is that for many company-driven projects, you need to open something. So basically you need to write a report that on how the workload was done, but then kind of the actual model that was created might not be kind of, or it can be kept closed. But this kind of depends on the company, size of the company, and also the call that has been used for the computing. And then we will also collaborate or look to collaborate with Business Finland in future and other national innovation funding mechanisms to allow companies to have kind of fully closed computing resources as well, when needed. And of course, as I mentioned, our consultation covers also all this, so you don't need to worry about the kind of the access calls. We can help you with that. And then kind of finally, to piece everything together, how would this now work out? So let's take imaginary example. This is actually imaginary example. There would be a hackathon on satellite data that's organized on some regional campus, maybe in Finland, Czech, wherever, for students. Okay, well, here we can already help in this point. So we can offer computing platform and we can offer a data platform just for running the hackathon. Then there's one very brilliant team, and they actually come up with the idea that might even make into a company one day. So they would like to start developing the idea, and they found a startup company. Okay, AI Factory can then jump in here, provide computing and data platform, so continue kind of the access they have. Also provide help on AI methods, and also importantly evaluate the technical feasibility of their plan. So we can kind of have a look, okay, that is what you are doing, and our experts suggest that you might do this and this. Okay, then the idea develops, and they can have a small product, minimum viable product. What we can do here, okay, now you have something, but you really want to evaluate it. Okay, is it really working? So we can help in getting some real-world data, larger data sets for testing out the product, and then also bring the kind of the platform for validating the minimum viable product. And then finally, when it's time to go to the market, then of course now our role will start to diminish, but we can still consult on the kind of the technical and compliance questions, so that getting to the market is easier. So one example on how AI Factory could help in a kind of quite comprehensive way through the whole journey. We have been working on this. There are many other examples from manufacturing and from telecommunications and then health. And importantly, okay, these are examples of a comprehensive solution. So we help you all the way through your journey. But also, AI Factory does not need to be a one-stop shop. If there is a network, if there's some actor that's already providing support on AI and only needs one piece, then we are very happy to help in that as well. So we don't need to bring our comprehensive service portfolio all the time when we are helping out people doing RDI. And that was my part. I don't know if we have any time for questions at this point, but during the poster session, I will be there with the extended set of slides. Happy to show you around, answer questions, get into more details, and there are also some other demos that you can have a look.
Okay, so we have time for a couple of questions. And questions. Oh, here we have the lady. Anna will bring you a microphone.
Thank you. Good afternoon and congratulations on the LUMI AI Factory. My name is Solja Sulkunen. I represent Finnish AI region, European Digital Innovation Hub, with the purpose to support SMEs in deploying and extending the usage of AI for their businesses. My question is actually to Aleksi. You mentioned about like one of your missions is to make data more available, the existing data sets that we have. Do you have any concrete plans or ideas how to make these existing data sets available that are now prevented by certain regulation, for example, or you mentioned the size of the data sets for SMEs to be utilized, and is there something that you'd need on this mission? Thank you.
Yeah, I guess this question has a very long answer, and I try to condense it. So, of course, it really depends on what is hindering data access. So size is maybe even the easiest thing, because we are a supercomputing center, so we have ways to deal with large data and deal with like how the data would be moved to the environment and how we can kind of maintain it for a certain period of time. So size is in a way easy. But then the regulation, it depends on the regulation. So for example, for medical data, it might be toisiolaki, so the Secondary Use Act. And here at CSC, we do have environments that allow you to use this kind of data. And now we are really working to basically bridge the gap between the large supercomputing clusters and those sensitive data environments. So we do have solutions for both of the problem of big AI and the problem of sensitive data, but they just need to now talk to each other better. Oh, I guess AI decided that it's time for me to stop talking. So for other regulations, then it really depends on what's the regulation is, and then we can find ways. Of course, the sensitive data environment will solve many many questions or kind of tick many boxes.
Okay, we have another question here, the gentleman here in the front.
Thank you. Congratulations. I'm Reidar Vasenius, represent Lexophon Limited. We provide top quality speech generated by AI. So as a startup, like many other startups, I think we're drooling when we see these slides and we hear about the resources. So I wonder what kind of criteria or thresholds there might be initially before we start bombing you with requests and training and consultation, etc.
You want to take it?
Yes, that was a very good question. And now I get the opportunity to say this. So to get started, you can go to lumisupercomputer.eu, and there you can find AI Factory page, which is a bit hidden there, but you can find it if you work hard. So we don't yet have our own domain. We will soon have, but now you have to go to the general page and find it through the launch kind of new piece, for example. And there will be a email link, so just drop us an email. We are happy to hear about your needs already this evening. We will not provide answer until tomorrow morning, but anyhow, please go ahead and get in touch. And to answer that, what's the threshold? Well, there's any startup company is welcome to participate. Of course, we look for users that really benefit from our services, and so that there is some kind of computing or data related need to be seen at least after some initial consultation, that we can get to something where our services are really necessary. So this is basically the only requirement.
Okay, thank you very much. I think that's all the questions we have for this time. And like said, we'll have Alexi and Pekka available during the demo and the cocktail hour. So next, we'll turn our attention to real-world applications. And our next speakers will showcase use cases from both industry and scientific research. And on that note, I'm delighted to invite Irina Sando to the stage. Irina is the Director of Destination Earth at the European Centre for Medium Range Weather Forecasts. And Destination Earth is a pioneering initiative of the European Union to develop a digital twin of the planet Earth. It leverages high-performance computing infrastructure and serves as a model for European cooperation. Irina's talk is focused on the synergies to be consolidated with the upcoming European AI factories and the LUMI AI Factory specifically, in order to redefine climate action. Please, Irina.
Thank you. Thank you, and thanks our close partner from CSC for the invite. It's a real pleasure to be here today for the opening of the LUMI AI Factory, and very glad to have heard myself more about it. This represents not only a huge technological advance, it really symbolizes a shift in how we tackle some of the biggest challenges of our times. And few challenges are more urgent and more complex than climate change. So today I will talk about how digital twins, such as those we are building in the Destination S initiative of the European Commission, and AI factories, which we heard already quite a bit about, can help redefine climate solutions and how can support European member states and you here in Finland to take climate action. So you may remember that you may have heard that the last 2 years and this year again, and you can see the graph on the left there, it's among the warmest temperatures on record. And these are data produced by the European Centre for Medium Range Forecast in the framework of the Copernicus Climate Change Service. You may also remember the devastating floods, the catastrophic floods in Valencia, or many tropical cyclones. You may remember any other of the 600 extreme events which happened only in 2024. The World Meteorological Organization classified 149 of these events as unprecedented, and they caused more than 1,500 deaths. The 10 most costly caused damages of over 200 billion euros. So the urgency is increasing with every fraction of a degree. And we need better solutions. We need more localized insights, and we need more flexible technologies to help support responding to extreme events and adapt to climate change. So this is where the digital twins come in, allowing us to move from the prediction systems we have today and complement them with more flexible, more interactive systems. So a digital twin is a replica of a real system created by blending cutting-edge numerical simulations, AI, and real-world observations to create a system which allows to test, understand, plan before we act. In the space of climate, this means mimicking basically what you see outside, the atmosphere, the sea ice, the lakes, the oceans. That's where a digital twin of the Earth comes in. And this is not a vision anymore. It's happening in the European initiative called Destination Earth, which started in 2022. This is implemented by us at ECMWF together with the ESA and EUMETSAT, the space and satellite agencies in Europe, and 100 partners in Europe. And some of them are here in the room from CSC, FMI, and some other institutions involved in Destination Earth. And Destination Earth aims to create a digital replica of the Earth, a highly accurate numerical simulation of the Earth system, of the winds, as you can see there, of the atmosphere, the oceans, their interactions. And this is a simulation. This is not the satellite image, what you see there, and has been created here in Finland on LUMI, which is really extraordinary. But the digital twins are not only creating beautiful pictures, they are really creating global weather and climate data with what we call local granularity. And you can see it again when the winds are coming in. You can see this high level of detail, and this was not possible until recently. But why do we want to mimic the Earth? Well, because we would like to have a flexible system which allows us to explore plausible what-if questions. We are building 2 digital twins in Destination Earth, one focused on extreme events, focusing on a few days ahead, allowing to respond to current extreme events, complementing what meteorological services like FMI or the European Center are doing, with more targeted systems to extreme events. But it also allows to look, and I think this is even more interesting, to look at the extreme weather events in the future and test specific adaptation measures. Then we have the climate change adaptation digital twin, and this the implementation of this digital twin is led by CSC with participation from many partner institutions across Europe and us at ECMWF. And this really allows to mimic the evolution of the climate and test adaptation scenarios for a few decades ahead until 2040, 2050. And look at how droughts, heat waves will change, for example, how this will impact certain sectors. And as well, this is happening as well. Last year, we have done the first unprecedented simulations at 5-kilometer global resolution until 2040. What you see there in this movie on the bottom corner at the moment is the simulation done on LUMI at 5-kilometer resolution. We've done this with 2 leading European models. And at the top, you see the information we have today from global climate models, which is about 100 by 100 kilometers. So you see this much higher level of detail. But it's not only that. I think the really exciting thing is the fact that we can run this system on demand for testing certain scenarios in the future, provided we have the computing power. But that's what LUMI AI Factory is for. The fact that this is a groundbreaking simulation was acknowledged with 2 prizes at the Supercomputing Conference last year on top HPC-enabled scientific achievement and the best use of HPC in physical science, which I thought it was a nice recognition. But the digital twin is for more than that. It really allows us to dig in recent events. For an example here, heat wave, which broke the temperature records in France in 2019, and explore how this particular event would look in a warmer world, in a 2 degrees world, with a level of granularity which allows you to look not only at the country, but really at the city level. You can see Paris in this little box there. But it also allows to use this information that we are simulating with high resolution for planning marine nutrients and fishery management, for example, or for planning wind farm portfolios or other renewable energy sources, or for adapting our cities by looking at thermal comfort indicators, for example, how heat waves in the future will feel. So we have achieved quite a lot already in the short span of 2 years of Destination S, but since last year, we are also boosting the AI activities, and that's the link with the AI Factory. So the AI revolution has not only opened opportunities in many other domains, but opens huge opportunities in weather and climate by allowing to even beat traditional models and that we do which we do the weather forecasts today, but also to do them faster. A traditional global weather forecast done by the European Medium Range Forecast takes 1 hour. A forecast done with an AI model takes 2 minutes, or even 1 minute. And Europe has done a great show of collaboration here, I think, because we have managed to build our own model, entirely AI-based model for weather forecast. You can see an example there on the right. This is a 3 days ahead forecast for Storm Boris, which caused, you may remember, the devastating floods in Central Europe in September, October last year. In the middle, you have the physical model, which is one of the best models in the world. And then on the left, you have the observations. So even for an extreme event, the AI model is giving better predictions than the physical model. It's not the case all the time, but this means that we are building a competitive model, and we are working with the National Met Services, among which FMI, to also construct regional zooms with these AI models. And I think this is really great. Now, of course, this wouldn't be possible, again, without LUMI and the Euro HPC supercomputers more general, because what you need to build an AI model, you need a very good data from the systems today or from the digital twins, and you need a world-class supercomputer, and you need more than that. You need an environment, like we heard before from Pekka and Alexi, of an environment which allows to rapidly deploy these models, train them, have all the AI-ready data there, optimize the models, and then run inference, run again, and continue to improve them. So far, we have built a weather model mostly for the atmosphere. In Destination S, what we have started to do, using digital twin data and the Euro HPC supercomputers, among which LUMI, of course, is to extend it to the other components, to the land, the atmosphere, the oceans, the sea ice, the hydrology, to construct as well, similarly to what we have with the physical models, an Earth system model based on AI, which can also hopefully go to longer timescales. And it doesn't stop to the Earth system, because what matters most is what happens is the impact. So it's the impact sectors, what happens for the impact sectors, like renewable energy, like food production. So we are starting to develop some demonstrators as well, but that's in particular where I think the AI factories will give us a boost. Why do we want to use AI in weather and climate? Because what I've shown, we have done a couple of simulations, but if you want to do reliable predictions and assess probabilities, you need to do more of these simulations, what we call ensemble forecasting in numerical weather prediction. And that is expensive with the physical models, but it's cheap relatively, once you've done the training, which costs a lot of GPUs, with the AI models. So the AI models can help us make more reliable predictions and therefore better informed decisions. They can also help us augment the interactivity of these digital twins, because of course not everybody can run the climate digital twin with the physical model, but with the AI model, a concept which we are working on at the moment is a forecast in a box. Instead of giving somebody the data, giving somebody the model and the initial condition to produce the data so that you can play with parameters and create the data tailored to your needs. Finally, all these models are creating a huge amount of data, 1 petabyte per day. You want the needle in the haystack. You need a piece of data. How do you get it out of there? And that's where the blend of climate data and LLMs can help. And CSC and their partners in the Climate DT are building ClaimSite, which is a prototype climate-aware chatbot, which will help answer questions. And in this example, it's about, can I grow olive trees in Bavaria? So it's really transforming, easing the access to information and helping to transform raw climate data into climate information. So the AI factories. For me, these are really the next level, because they allow us to complement what we have and what we are building with much more performant systems, much more performant environments, which help to deploy these models faster, to do the training, because all the data will be there, and really accelerate the creation of applications which support decision making. It can allow, for example, to build I think where it can help in particular is build an AI layer on top of the digital twins to really help translate the raw climate data into climate information for specific sectors. For example, one could develop, and hopefully many of the SMEs here in the room would want to do that, use the digital twin data to create applications tailored to cities, to then run the AI application to see how to do urban planning, for example, how to adapt the city in the future, or how to better operate renewable energy parks, or how to plan better energy parks, where to plan them in the future to maximize investment. So I think we are really shifting from a bit of a more static world where we are doing reports for informing climate action to an interactive system where to plan we use more interactive approaches and more integrated models from Earth system to impact sector to support European member states to better respond and adapt to climate change. So coming back to their talk before, we have the data, we have the compute, we have the talent, and we have a very strong network of collaboration in Europe. This is where Europe really has a lead. So, and now we have the AI factories, which are the factories of the future, not producing emissions, but producing solutions. So let's exploit this opportunity to push boundaries and better respond and adapt to climate change. Thank you.
Thank you, Irina. Like in the first session, we'll take the audience questions after the three presentations on use cases. Now, it is my pleasure to invite Pekka Rosenvuori on stage. He is an associate professor of the Institute of Biomedicine at the University of Turku and leads the Compat AI, an effort focusing on AI-enabled computational pathology, developing new ways to model histopathological tissue samples with generative and predictive AI. Pekka, please.
Thank you.
Do you want to use this?
Can you hear me all right? No? Okay, maybe that one.
I think it works.
Another try? What about now? Yeah, somebody raised the thumb.
All right. Nice to meet you all. My name is Pekka Ruusuvuori, coming from University of Turku. Very honored to be here to get the chance to talk a bit about our research on how computational pathology benefits from high-performance computing, or should I say that how high-performance computing enables doing computational pathology. All right, just starting by showing the stars of the show, which is obviously the researchers in my research group, and also very thankful for all the funders without whom this work couldn't be done. Also like to highlight the logo of CSE there. I can truly say that none of this work that I'm showing you could not be done without the access to the high-performance computing services provided by CSE at this scale or at this level. So that is really it's not just something that is nice to have, but it's actually something that enables doing this work. More names. So there was the abbreviation Combat AI. Before I actually go to the topic of my talk, I of course need to introduce the people behind that. So in addition to the computing power provided by these high-performance computing services, we also need the expertise, as was mentioned in this earlier talk. So it's all about combining data skills and the capacity to process the data. So in addition to the AI knowledge, we also need, this is highly interdisciplinary work, so we need the expertise of pathology and histopathology worlds. So two names, adjunct professors, Leena Latonen from University of Eastern Finland and Teemu Tolonen from FimLab Laboratories and Tampere University Hospital are the ones who actually know about the histopathology world and know how to interpret the results that we are computing there. But the consortium, the goal of the consortium is really to build large-scale computing systems to interpret and analyze histopathology data. We have had LUMI G extreme scale access projects for a couple of years now, and through that we have enabled using really large-scale computing resources for analyzing large scale of massive histopathology data sets. I'm going to talk about that in more detail in a few slides. Also the funding from Research Council of Finland, which is particularly meant for this high performance computing, is highly appreciated. So let's see if I get this video running. I think it should start from here. So I'm not a pathologist, so take it with a grain of salt. So I'm a computer scientist. But the data that we are processing is indeed histopathology data. So the basic form in which it comes is a small glass slide on top of which there's a thin section of tissue, which is then stained to make it visible. And you can see this nice purple pink structures in there, which is the actual tissue, and zooming in, you can see small details like individual cells, individual nuclei, even the chromatin structure within the nucleus. Which for the experts, like for the pathologists, they tell about the status of the tissue, whether the tissue has the disease like cancer in it or not. And of course, that interpretation goes beyond my knowledge, but now, instead of looking at the glass slides, we actually look at digital images. So what digital pathology means is that we digitize these glass slides into high-resolution images, which basically are multiple fields of view taken under a microscope, stitched together to a very high-resolution digital image. For a computer scientist, it means that we have a lot of data. The individual image consists of tens of gigapixels alone. So an individual whole slide image, as we call these, contains more data than most of the benchmarks that are used traditionally to evaluate AI and machine learning methods. And if you have thousands, even hundreds of thousands of these slides, you have enormous amount of data, even up to petabyte level. And the goal of computational pathology is indeed to provide decision support tools for the experts, for the pathologists. For example, to make the diagnosis whether the patient has a cancer, or what is the aggressiveness of the cancer, and so on and so forth. So speaking of these decision support systems, so let's take a look at a few examples of what AI can do with these digital images. Deep learning, as we know, has changed a lot how images are interpreted computationally these days, and the same applies also to medical imaging, like for example, digital pathology. And now this is a case study with prostate cancer. And using these high-resolution images, we would like to have a system that would help the pathologist in viewing the tissue and giving a hint that there may be something suspicious going on in here. Maybe you want to take a look at this area, there's a hotspot in here, maybe there's cancer in here, and perhaps the cancer has the grade 4 or 3, and so on. So that would greatly speed up the process of looking at this tissue and hopefully also reduce the subjectivity, because some of these measures are by nature very subjective. So for example, the Gleason grading in prostate cancer is known to be highly subjective. So it's basically interpreted as visual patterns. So there's no strict division in between these different grades. And if we would have an AI system supporting the pathologists, there's a big hope that it would actually reduce the subjectivity in between the individual experts. So that is what we try to build. So first of all, the question is whether we can find the cancer from the benign tissue. And it seems that these deep learning-based systems are very good in that. So they almost perfectly work, so they don't miss any men with cancer, and also they don't do any false positive detections. So it's close to perfect accuracy in finding the cancer from the patients. But the tricky part is the Gleason grading, the subjective part there. So what is the aggressiveness of the cancer? And even in that, this deep learning-based system seems to really provide a reasonably good accuracy. I suppose, like comparing to the bunch of highly expressed international experts, uropathologists in the field, if we are among those accuracies, the deep learning-based system is the gray dot in here, so it's not perfect, but it's like within the range of the international experts. So we can be fairly happy with that, but we still wanted to improve it, and indeed, as mentioned by Alex, so if we have the skills, if we can provide the data to those who have the expertise in building the AI, we can truly come up with the great solutions. And we tried to crowdsource the solution and provided a huge data set, 11,000 whole images in a contest, and we got over 1,000 teams participating in this Gleason grading contest by AI, and within like 10 days of the release of the data, they already achieved accuracies that were outperforming the current solutions by pathologists or even by previous AI systems. So it was really a great success, and really just underlines the importance of providing the data, getting access to the data for the large masses of machine learning and AI developers out there. That sounds good. I mean, if we can build these systems, why are not they used everywhere already? Well, there are some remaining challenges, obviously. So one of them is actually how the data is produced. So staining processes is one of the largest or main sources of variability there in histopathology. And this slide is just to show you the range of variation in generating the stained slides from histopathology sections. So this is an example where we had 66 labs doing H&E, hematoxylin and eosin staining, for individual sections coming from the same block of tissue. So basically, what you are supposed to see there is the very same piece of tissue stained with the same protocol by different labs. But the appearance of the staining is completely different throughout the individual panels. And you can imagine that it may trick even humans. Well, humans are actually very good in kind of like tolerating these differences. But if you feed this data to your AI system, it will fail miserably. Most likely, it will not be able to provide you the same answer from these different sections, even though the tissue should be exactly the same, like different sections from the same block of tissue. Another thing in building these AI systems that I showed you is that they are relying on supervision. They are relying on somebody telling that where do we have this disease and what is this disease, what is the grade of the disease. But what we would like to do is to have more flexible solutions, more generalizable solutions that would require less training and less supervision, and to be able to more agile manner train the solutions to different diseases and different use cases. And that's what we are aiming to do in this Combat AI consortium. So we would like to build foundational AI models using population-level digital pathology cohort from Finland. So in Finland, many hospitals have already adopted digital pathology. For example, Tampere and Turku are basically 100% digital these days. So every single diagnosis is being done using digital pathology instead of the traditional glass slides. Helsinki is about to follow them, and many other hospital districts, or rest of the hospital districts are supposed to follow also in a couple of years. So Turku and Tampere alone produce some 600,000 whole slide images annually, which means that roughly there's almost like a petabyte level of data collection annually produced by these two places. So could we somehow benefit from this large mass of data, and would it enable us to build something that hasn't been able to be done before? So we would like to combine this massive data generation to the high-performance computing services by CSC on LUMI, and also, of course, the expertise on AI, which is very strong here in Finland, and there's plenty of experts also working in these groups together. So the goal in the end would be to use all this data without actually having any supervision, just combining all the data, feeding them to the self-supervised deep learning model, and building a foundational model using Finnish population level data. And that work is ongoing. Currently, we are operating with roughly 150,000 whole slide images, and we aim to get to 1 million slides in a year or so. All right, just to provide you with some more food for thought, so a couple of use cases from different areas, instead of just doing the diagnosis based on these whole slide images, is that how could we combine genetics to histopathology using AI approaches. And a study done a couple of years ago together with my group and some Swedish researchers showed that we can actually predict the gene expression levels directly from histopathology data. And this is something that was shown for individual genes, but we wanted to scale up this approach and do it on a whole transcriptome level. So humans have, like, according to the current knowledge, some 20,000 genes. So can we actually predict, and how many of these genes can we directly predict from histopathology? The expression of these genes. So we took on the challenge with the help of the CSC's Grand Challenge pilot project that we were granted. And we built an ensemble of neural networks for every single gene. So 30 neural networks per gene, and almost 20,000 genes means that we had 500,000 to 600,000 neural networks trained on Puhti, which is quite a remarkable effort given the large size of the images. But we were able to do that, and indeed it was pretty surprising for us that over half of the genes could be predicted statistically significantly directly from the histopathology slides. So this is something that was not known before. And what it means in practice is that a panel, gene expression panel done for a sample, it costs like 100 euros or so. And if we can do it directly from histopathology and not do this gene expression panel, we can reduce the costs of doing this gene expression based profiling of patients significantly. So this is really a cost-efficient way of doing this. Other examples of going beyond what the humans can see. So indeed, gene expression cannot be seen by the pathologist directly from histopathology slides. It's something, there's some small cues that the computer can predict based on the AI, but the humans cannot see it. Another example is prediction of mutational status from histopathology images. That's another thing that is very hard or almost impossible for humans to see whether there is a mutation there or not. And that's what we did together with researchers from Tampere and Helsinki to try to predict the presence of mutations in leiomyoma samples, which is very common among women, even though it's not deadly, but it's still socio-economically very large burden. So it affects almost 1 in 4 women here in Finland. And it turns out that whenever we have a lot of data from these patients, we can predict the status, the mutational status. So from those mutations that were commonly present in this sample cohort, we were able to build models that predicted very accurately, which means that, again, we don't need to do the specific panels to measure whether there's the mutation or not. We can just use the histopathology slide, which was not also known beforehand. As a last example of efforts that we are doing that go beyond the capabilities of human visual system is to predict the staining. So I showed you the common way of processing the samples. Is you take the thin section of tissue, then you stain it to make it visible with chemicals. And it actually takes hours, even days, to do it. And the chemicals may be expensive, and for sure they are toxic for the nature. So could we actually predict the appearance of the staining by using the unstained section, imaging the unstained section, and building a model using generative AI to predict the appearance and the presence of the stains on top of the tissues? So if the traditional pipeline goes like this, so you take the tissue sample, you process it, you section it on top of the glass slides, and then you do the staining with chemicals, and this takes a long time. Then you do the scanning with the high-resolution scanner, and then you have the digital images which you can use for computational pathology or just interpret by looking at them by the pathologists. What if instead of doing the staining, you would just directly do the imaging and then use AI for predicting the appearance of the staining? It would be handy, it would save a lot of time, effort, materials, and also chemicals. So a sustainable approach to do histopathology. And here's some of the results from our previous studies on this area. So the left panel shows you the unstained tissue imaged with the scanner, and this is what the chemical staining looks like, and this is what the virtual staining, as we call it, like the predicted using generative AI stain looks like. And there's clearly, on a macro level, a very high level of agreement between these, and currently, as I'm speaking here, the rest of my group is working on this topic and finding out whether we can use this on a clinical level material using breast cancer samples. And of course, there's much more than just H&E, this pink and blue staining. There's many special stains, and we are also working on multiple different stainings to see that which ones of these we can actually replace by doing the predictive or generative AI-based predictions. Just a few words about translating the research results. So this is all very fun and interesting, at least for me. I really love the work of doing research. But there's more to that than just doing the research and writing the papers. We really want to have an impact with this. So there's so far been 2 startups from the research done in my group or by me, and we have plenty of patents or invention reports from our work, so trying to protect a little bit of the IPR, but of course we are also all for the open science these days. But we are also participating in several ongoing clinical trials just to kind of like bring the AI closer to the benefit of the patients. So 3 of them are in Finland, and 1 of them is multinational, led by Swedish researchers. I'll end up with a few wishes for speeding up the innovation cycle. This is purely from my researcher perspective. So how could we benefit even more from this? So for example, the massive scale of these data sets means that it takes actually a while even to transfer the data, let alone use it computationally. So even though we have plenty of computing power, it still takes a long time. So it'd be nice to get a bit more longer periods for these extreme scale access projects. And also, of course, so all of this takes a long time to really set up. So we really would appreciate continued funding support from the funding agencies as well. And regulation and data access is something that along this secondary use of medical data laws and all the discussion going on in there. So just an example, it took us over 2 years to get the permissions and all the bureaucracy tackled to get going with this use of the massive data set that we now have access to. And 2 years is almost an eternity given the speed of how fast the AI world is moving these days. So if we can reduce the time needed for the paperwork, it would be highly appreciated. Having said that, so we are really grateful for all the support and all the resources we have been given. So thank you very much.
Thank you, Pekka. Our next speaker is Ozan Genzolu. He's the co-founder and head of AI at Root Signals AI, a startup looking into solutions to assess the reliability and quality of LLM-powered applications, valuable tools for companies and researchers looking to build safer and more efficient AI applications. Please, here you go.
Thank you very much. Hi, everybody. My name is Oz. My background is in machine learning and AI, doing that for about 15 years in all kinds of settings. I'm one of the co-founders and head of AI at Root Signals. On the side, I'm advising OECD AI policymakers. They don't necessarily listen to me, but they want my advice anyway, somehow. Yeah, very pleased to be here today. I'll be talking about measuring, evaluating, testing LLMs and LLM-powered applications. And my title is, Can we control generative AI without measuring it? No. Thank you. That was my talk. How many more minutes I have? Yeah. Jokes aside, it just doesn't work like that. And I have a couple of maybe slightly provocative questions. So why is that almost trillion euros, I'm not exaggerating, is poured into Gen AI with whole compute and all the research, all the companies, everybody and their grandmother is building chatbots. And why do I still have to reply my emails? Well, why can't that be completely automated? I'm asking a genuine question. So the return on investment of Gen AI is pretty much zero right now. The whole world is betting on this. There's just too much money on the table. Okay, maybe except spreading massive amounts of misinformation on TikTok to meddle with elections. But in general, we still don't have that killer app yet. For sure, it will be coming. But we claim at Root Signals the main reason for the main answer to these questions is because LLMs are just unreliable. And I'll be talking about that. And the LLM we trained, Root Judge, I'll be quickly mention about that, of course, in LUMI, and a couple of misconceptions about LLMs. So every day you see all kinds of claims from all kinds of companies, from these frontier AI labs. Hey, we beat best mathematician in theorem proofing, and doctors will be gone because AI passes the law exam and all the doctors and all kinds of things. And we claim this is just the maximum performance kind of edge case performance of these generative AI models you see on the news. But I'm not theorem proofing. I don't care. My colleague is asking 1,000 questions per minute on me in Microsoft Teams. I need to reply to that. I need to find some information from some Google Drive, or I need to support some customer. I don't want that. Who wants to talk to their customers? I don't want to find information faster so I can do all my tasks faster. I don't care. I want some of the tasks completely automated. And this is a completely different mindset. I don't want to do the same tasks 30% faster. I want 30% of the tasks completely automated. And these things don't help me because I want reliability. So why are LLMs unreliable? Because they are non-deterministic. That's a fancy way of saying if you ask the same question today and 5 minutes later you will get different answers. And they're not self-conscious, they don't have self-reflection, so you can't write in the prompt, please don't hallucinate. It doesn't work like that. They can't assess their own uncertainty. And as this is not enough, they have a thing called prompt. So the whole answer depends on what you write, the question and the query you are asking and the instruction you are telling. So how do you even measure that? It's free text. So that's why LLMs hallucinate. They talk a bit weirdly. They are unreliable. You want them kind of, they are a bit too chatty sometimes, all kinds of things. So for your LLM applications, there are multidimensional failure modes. So evals, or evaluation and measurement, it's not a new thing. Of course, I have been evaluating machine learning models I've been developing with my teams for decades, but it was not a problem before generative AI. It was just calculating accuracies and ratios, so precision recall. But now it's hard because it's just free text. It depends on what your end user is asking. You don't know that beforehand. So this is the problem we are trying to solve at Root Signals. So our solution to that is specifically fine-tuned LLMs trained and tuned to perform evaluations. So AI trained only to evaluate output of all these AI models. So this is called LLM as a judge in the community. AI community is not some term we invented. So LLMs specifically fine-tuned to evaluate other LLMs, detect hallucinations, and all kinds of things like that. And that's what we trained at LUMI. So we trained Root Judge. It's completely open source, open weight. You can also use commercially available. We gave it to the community. So it's a state-of-the-art LLM trained to perform evaluation, hallucination detection. Actually, we beat OpenAI, Anthropic, all these models specifically on that thing because that's what it's trained on. So these sort of evaluators and measurement devices you can think of, that's what we are building and providing at Root Signals. A couple of misconceptions about this LLM as a judge, LLMs judging other LLMs. So one misconception is this is just it's just to detect this one-off rare case LLM says something silly or hallucinates. So this is not the case because the metrics you care about, they are complex. They are stuff like, hey, I built a chatbot. I wanted to talk about my company tone of voice. And of course, this is not binary 0, 1. There's like levels to it. So you want to have grades, shades of gray, and you want that sort of measures and grading and scoring out of your LLM applications. So it's not just this is correct or not kind of thing. The second misconception, when AI labs are giving more and more powerful, smarter models, we don't need to measure them anymore. This is, of course, pure cope. That's not how it works. So when the current tasks we demand from LLMs and AI, okay, the hallucinations in these tasks will be solved, but we will demand more complex tasks. So the goalpost always moves. So we always want to measure because we need reliable stuff. And the maybe last misconception is these LLM judges, meaning evaluators, they're only for, while building my application, I can test, is this prompt better or is this model better than the other model? No, actually we evaluate our clients, using us, they evaluate every single response of their applications. And there's a great paper by Nature. It says that LLMs are unreliable, meaning that LLMs, the latest models, they can do pretty complex tasks, but they can still fail in super simple tasks, meaning that you cannot divide this, you cannot draw this line. These tasks I can completely automate reliably. Let me repeat that. LLMs can do really complex tasks, but really fail in very, very simple tasks, which is really a bad deal because I want to automate things completely. And even a bigger bummer, larger and smarter models, they are less reliable. Larger and smarter, all these OpenAI O1s and all that, they are less reliable. It's even more difficult to draw this line. These tasks, even though how easy they are, they will be working perfectly. So you need to measure everything all the time. And that's what we build at Root Signals, building constantly. So my last slide, you need to measure stuff. LLMs are unreliable. This is not going to be solved. It's just by the nature of neural networks. So we are not claiming any exotic. You need to measure stuff. So this is like very fundamental. I almost can't believe I have to start a company to solve this problem because people are not measuring, they're just prompting. And this lack of reliability, in my opinion and in our opinion, this is the main blocker for large-scale adoption. It's not cost, it's not nothing of that sort. It's because it's just unreliable. And you need to measure to rely and to decide, can I automate this? You need to measure that. And these metrics you care about, they are complex things. This chatbot, I don't want to talk about my competitor. I want it a bit formal, but not too formal. I want it to comply with my company policy. All kinds of complex metrics. You can only measure that by other LLMs as a judges, which we provide in a systematic way. Yeah, thank you.
Thank you, Oz. So now we have some time for questions. Oh, Oz, please, can I just have you stay here? And if I can get Irina and Pekka also. So if we have any questions in the audience, and we'll get you a mic. We have here in the middle here.
Okay. Well, I want to ask about evaluations. Well, since in the last slide there was a number list, and the first item was that LLMs are unreliable. So it's how would you then say that using LLM judges is the best way to evaluate these models?
We have two answers to that question. One, what you are coming to is that if LLMs are unreliable, and if we are building these LLM-based evaluators, we are putting even more unreliable stuff on top. How does that make any sense? And that's why in our product, we actually provide you a systematic way to evaluate the evaluators themselves, meta-evaluation, so evaluate the judges. But and the second answer to that is that because our evaluators or LLM judges, they're not trying to do everything. So ChatGPT is trying to be good at giving risotto recipes and all kinds of things, but our evaluators are only doing one thing. So they are, of course, very, very good at only that thing. So they are much more reliable than general purpose language models. And thirdly, because LLM judges they're not perfect either, LLM judges might fail. That's why I shouldn't evaluate. That's of course not the conclusion. So it's better to evaluate, even though the evaluators, the measurement devices, might every now and then make some mistakes.
I had a look at the Hugging Face page of the model. You mentioned that was I think that was a fine-tuned llama model, if I'm not mistaken. Yeah. So what did you make the decision of using generative models for evaluation instead of, say, an encoder model, where you would sort of, you could do something like zero-set classification and sort of like compute a probability of some label you want to assign. But so what do you think are the advantages of using generative models?
Yeah, this goes a bit technical, but the reason is that we don't know exactly what our customers want to evaluate. They can build their custom evaluators specific to their company. Let's say their company has a communication policy and they build a chatbot. Is this thing complying with this company communication policy, which is like 50 pages long, and this sort of things? So it has to be we can't turn this into a binary classification problem or thing like that. So it has to be prompted, and it has to be generative because of the complexity of the metrics people care about in all these use cases.
Okay, now do we have another question in the end? Don't be shy. Okay.
Yeah, we are ahead of the schedule, so we need to have a lot of questions now. So it's anyway, but I actually have something for Irina. So now we talk quite a lot about the Destiny Digital Twin. So in the climate. So how applicable the technologies, the digital twin technologies, are in other areas? So can there be some kind of cross-disciplinary collaboration?
Yeah, that's a very good question, because for now in Destination S we have done a digital twins on weather extremes and climate change, but there are many other digital twins emerging in the community in Europe. And here a few at CSE you are working on few, like biodiversity is one, but there is also a digital twin of the ocean. There are various digital twins of geophysics. And I think now what we need to focus on is how do we make this interoperable, even if we don't combine them all in one. But I think what's essential is to have to make the technology interoperable so that we can couple these digital twins. And there are different degrees of coupling. Some can be tighter coupled, where the models run on the same HPC and feed one another, and there is one-way or two-way interaction, but it can also be a weaker coupling, more downstream than some of the digital twins, like biodiversity, ingest the climate data and then they use their own things. So I think the idea is really to build an ecosystem where the various digital twins, which makes sense to couple, we can couple them.
Kai Lehtinen, Top Data Science. Also, how did you use LUMI? So some best practices, how you were really able to utilize that, and how are you seeing using those resources going forward? Very interesting to me.
Yeah, we of course want to thank LUMI, because large language models are pretty compute intensive. You can't train them on your gigantic GPUs and things like that. So definitely this had to be done in a large scale. And how we use LUMI is mostly post-training. So we took a baseline model, Llama from Meta, which has permissive license to do these things, of course. And then what you do is you do supervised fine-tuning, it's called. So you collect significant amount of data, and this data is free text input and output. And we created a lot of synthetic data with other LLMs too. Synthetic data meaning that we took a bunch of text and created questions and programmatically inserted hallucinations and wrong and slightly weird answers to kind of diversify, to kind of increase the diversity of the data. And the training on LUMI took, we trained on about close to 400 GPUs. And it took, of course, some time. And we ran this with, you know, neural network training. It's a bit shaky. You need to a bit find the correct hyperparameters to see the, we call it convergence, so to sweet learning. And we could only do that because we had LUMI computing and that sort of luxury. So otherwise, you need to spend a lot of time and money on other kinds of, well, cloud computing providers. But with LUMI, we could actually hyperparameter optimize all these parameters of the neural networks and run several models and pick up the best one. And for the best practices, I think we have contacted LUMI people, CSC people many times. They were really helpful. It's not necessarily that you will face problems, first of all. This is just, the field is very new and the libraries are updated almost every week, things break. And that's just the nature of doing cutting edge state-of-the-art research. But LUMI people were really helpful. I think my biggest tip is just contact them. They know a lot. And I mean, I'm not just writing an email. In the code level, in the command line, we were like debugging with CSE LUMI people, that level of support. So that would be my biggest tip. Don't be afraid to ask for help, and they know a lot. Then maybe documentation can be also improved. Maybe that's the feedback to the LUMI people.
Okay, we have a question here in the second row.
Thank you. Timo Savolainen, thank you for having this launch event. I really appreciate this. This is something that we really need in Finland and in the EU area. Especially thank you, Irina, for bringing up this climate aspect. We don't need these funny cat videos what can be generated with AI. We need this kind of actions and what our in Finland especially social and healthcare really needs this kind of systems that we are now building, and this is something that our nation, I look from the Finland perspective as we are here in Finland, and I really enjoy that this is called LUMI, as we all know it means snow, and we have snow here in Finland. Maybe a question related on the Nordic level. Could we have a Nordic AI powerhouse? So extending this to the Baltic countries, Sweden, Denmark, Iceland. So really, if you remember the Game of Thrones, so AI from the north, could we have that? Thank you.
We already have it. I mean, I will hand over to my friends from CSC, but for the compute part. But the collaboration in the Nordics is extraordinary. I mean, first of all, in the climate DT, it's led here in Finland, but it's collaboration with other countries as well. But the other digital twin as well on extremes, there is a very strong participation from the Norwegian Met Service, from the Finnish Met Service, from the Swedish Met Service. And the Met Service is in general, and all the predictions that you see on TV, they are done by your national Met Services, and there is a very strong collaboration actually on AI for applying AI to weather forecastings. They are the leaders in the field, and they are developing regional models with AI to complement their physics-based AI models. So I would say we have it, but I give for the compute part, I give Pekka the word. You have it. Not sure.
Yes, thanks for the question. I don't know, can I get the mic on? Thank you. So yes, indeed, we have a Nordic powerhouse already. It's the LUMI consortium and a LUMI collaboration. It involves all the Scandinavian countries and as well as Estonia. So there is a deep collaboration from the consortium. Unfortunately, well, Sweden decided to go their own way for the AI factories, but then again, Norway, Denmark, and Estonia are still part of the LUMI family now, also with the LUMI AI, and obviously we're gonna do a lot together with the MIMER, the Swedish AI factory. So it's also, we just like keep up the collaboration, and it's just gonna have a kind of two places or two poles. So I don't know if Kimmo wants to elaborate on this one as the leader of the consortium. So
we have a question here, gentlemen. On the...
We also had a question here, so maybe I'll go here first and then.
Hello, hi, Roope from AMD. Thanks very much for the very good presentations. Maybe for Pekka, like amazing research you have been doing. Kind of what is needed, what could be done to kind of accelerate so that we see those also in real life and not only just as academic papers. So kind of what we could be doing as an ecosystem here.
Thank you. Excellent question. I would love to see these solutions going closer to the patients and actually benefiting the patient, but there's obviously there's a lot of regulation there to actually get there, which is good. But to speed up the process through this regulation, and also of course it comes back down to money again. So it's not up to the researchers to kind of like build the software, build the tools that can be used there. So we need the third parties, we need the companies involved. So I know there's plenty of like accelerators for the startups and so on. But what's really needed to kind of like bring the money there so that we could get the resources, we could get the people working on this, because I know, including myself, there would be plenty of interest to actually do this and like start new companies on top of these solutions and bring them there. I would say that the first thing is money, but also maybe I don't know, maybe we could do something to speed up the regulation part as well.
because the groundbreaking simulations we did, of course, we did part of them on the AMD GPUs. And I would say what we need most is not money, but it's a closer collaboration. And maybe you've heard that, how much it was a team effort with lots of us texting at night and working with your people. But I think it's really needed the collaboration between the tech companies who are building the hardware, but also the software around it, the centers like LUMI, and the scientists who are doing these Earth system models, in our case, the medical models. It needs a co-design and a close collaboration if we want to be at the cutting edge.
Question on this side now.
Question for Pekka, because I already know Zoo's work, which is really fantastic. This is Nitin Sani. I was wondering about the staining process that you brought up in those micro slides. Could there be some normalized form that is generative, that a better representation of that allows for better computation of those features? Or is it that we need to have the staining so that we can have physicians actually continue to examine these based on the practices they've learned? So I just thought to just reconcile that issue in your work.
Yeah, please correct me if I got it wrong, but I would like rephrase your question that do we need the staining at all? I mean, or could we have something that is not actually like representing the same staining that has been done over a century already? The answer is that I hope that we would get there, but to actually kind of like enable it first, we would need to convince that we can do it reliably enough. We can't break the current system, which is indeed like the H&E staining has been around for over a century already. So we need to first do something that the pathologists, that the experts can use right now to convince them that the computational solution is also as good. But in the end, I mean, if you can predict the staining, you could just as well predict the same things that the pathologists are seeing from the stained images directly without any staining, or to generate an artificial staining that is optimized for something that is currently not possible to do with the chemicals. Excellent question, and I think there's plenty of potential there.
With Irina, really inspiring to see these climate models in simulation. There is a slight contradiction in all of this, is that we're using these large supercomputing infrastructures, which also produce a lot of energy, and there is a responsibility for making that sustainable as we replicate these AI factories all around the world. The issue, this is maybe more a question to CSC, is how do we understand the carbon impact of what we're doing with these systems, and should we build in some kind of metrics that when you do computation with CSC, we also look at the carbon impact of that and try to mediate that?
I will hand over to Pekka, but just to say that we are really pleased to do these groundbreaking simulations and that they were carbon negative, but I'll let him explain.
Yeah, so LUMI, yes. So we have the, so I mean, that's a very valid question. So how much we can afford CO2 emissions to make science? It is like a truly justified question. Luckily with LUMI, the thing is that we do 100% CO2-free energy. So we do hydroelectric energy and reuse the excess heat on the heating the Kajaani city. So in a way, while the energy company can reduce the burning of fossil fuels as they got 10 megawatts of heat from us, so they can in that way the total equation is actually carbon negative. So in that sense, running the pixel simulation and LUMI is actually like a negative, like a carbon footprint. But that's of course not the case with basically any other supercomputer. So how much we can afford on an environmental footprint for furthering science is something that's like it's a clear a valid question.
Thank you.
Do we have another question here? Okay, yeah, we have in the back.
Yes.
Hi, Tarmo Toikkanen from Sitra. Maybe have a question for Irina and Pekka. Just think that in general, AI methods get 10 times faster and more efficient every year. In general, just think about do you see the methodology of sort of the groundbreaking methodology you're doing with using AI to deliver results, do you see those being translatable to other fields? So in terms of digital twins, do you have some new things that could be adopted by, let's say, researchers thinking about digital twins for humans, or for Pekka, do you have some methodology or some breakthroughs that could be applied for radiology type of medical diagnostics? Thanks.
I think these methodologies are transferable. I mean, weather forecasting started a bit later than the application of AI in other domains. In 2018, I think we did the first trial at the European Centre, and we said this will never work. And then here we are a few years later, and we have the first operational AI forecasting model. And we learned from other disciplines. So I assume that this translates to other disciplines. And now we've done it for the atmosphere. We already have prototypes for the ocean, the land, which are not they are not the same processes. They are much slower timescales. We are seeing systems being built for renewable energy. So I'm sure this is expanding, and we can learn from each other. And that's why cooperation and collaboration and interdisciplinary initiatives like Destination Earth are important to exchange knowledge and pool resources together.
Yeah, and continuing to the medical side, so definitely the modality transforms are something that can be done. So I showed you virtual staining, so stain to stain transformation or unstained to stain transformation, but the same can also be done from modality to another. For example, histopathology is very high resolution, whereas radiology or for example spatial transcriptomics, which is extremely expensive as well. So those, if we would like to build like high resolution versions of those, we could try to utilize these high resolution histopathology images and build modality to another modality transforms, which we are actually also working on at the moment. So yes, definitely, but also beyond medicine. So of course, none of these techniques, none of the technology is actually specific to medicine as such. So for example, I have background in remote sensing and process industry and printed electronics and whatnot. So very similar approach is also applicable in there. Particular remote sensing is something that is also in agriculture, that these days it's very common to utilize these type of methodology there as well.
We have time for one more question. So we have here in the front.
Hi, thank you. I'm Tuomas Tikkanen. I'm the EU advisor to the Prime Minister of Finland. This is more of a policy question, as I'm not a technical expert myself, but working on EU matters myself, we have been following the Euro-HPC network and, of course, very proud of LUMI here. How do you see the opportunities Euro-HPC network offers for your work and for innovation and collaboration across member states in the EU? Thanks.
So, should I? Yeah. Well, I would say that there's plenty to be explored. So right now it seems to be like sporadic. So individual groups working on their individual topics, but there's plenty more that we can achieve like internationally as well. So there's plenty of room for collaboration within Europe and beyond.
Destination Earth is the only strategic initiative for Euro-HPC at the moment. So Destination Earth has 5% allocated from the existing Euro-HPC machines. So definitely we are certainly taking advantage of this opportunity, and we are not only running here on LUMI, but we are also running on Mare Nostrum in Spain and Leonardo in Italy, but also on smaller systems like Melusina, and then the bigger systems are appearing. So something as at the cutting edge, and so such high resolution simulations, we couldn't do them if it was not for the collective power of Euro-HPC. And I think such a large scale collaboration also facilitates the collaboration between the sites. And in the climate digital twin that CSC is leading, they are working, for example, very closely with the Barcelona Supercomputing Center, and this facilitates exchanges and learning from each other. But also, this can facilitate as well the experience in Destination Earth, can also facilitate the setup of the AI factories, because we have onboarded in destinations alone 200 scientists to work on LUMI, and a couple of, Anna knows, another 100 probably to work on Mare Nostrum. So they learned from each other in this experience, in onboarding, in collaboration, in working with the vendors on the hardware, but also with the sites on the software. And how do we make things more interoperable so that a company which goes on €1 HPC doesn't struggle as much when it goes on another HPC, and we have portable codes. This is very important as well.
Okay, thank you so much. Did you want to, sorry, did you want to add? Okay, well, now I think we're going to move on, and thank you all the use case presenters, and it was very enlightening. Now, please join me in welcoming our next speaker, Peter Sarli. He is the CEO and co-founder of AMD Silo AI, the largest private artificial intelligence lab in the Nordics. He's also a professor of practice, specializing in machine learning and artificial intelligence, and is involved in the key European initiative, Open Euro LLM. Please, Petra.
Very good. Thank you for having me. As I understand, I'm in between Kimmo and the minister and eventually drinks. So I'll try to be brief. And I'll say a few remarks on, of course, our first-hand experience. But then I think the title was Europe's Competitiveness and Growth, and then so I'll try to tackle that part as well. We obviously have had for the past several years first-hand experience on LUMI, and as was highlighted earlier, both in the multilingual language models that we have been building, but also in the new Open Euro LLM initiative. I think one of, if not the largest open source AI initiative that the Commission has funded so far. We are not yet a strategic initiative, but I do think an important one for Europe's AI infrastructure going forward. So with Open Euro LLM, then building the next generation of open source large language models for European languages. Now, as you've heard, and unfortunately I missed some of the presentations, but luckily I do know most of the initiatives from before. I think there's been sort of tremendous innovation happening on LUMI, both in terms of companies innovating. We've actually also had the opportunity to work together and share experiences with some of those initiatives, such as root signals. Likewise, we've seen that there's been tremendous innovation when it comes to AI research happening on LUMI. Of course, Euro HPC more widely, but specifically on LUMI. And I guess this is the bridge to the sort of actual short comment. I do think this is crucial for Europe's competitiveness and growth. And I guess you could take many different angles to this, and it's an extremely complicated topic as such. And I obviously partly was joking that we will be tackling that topic. We won't be tackling that topic, but I think we can touch upon some of the key elements why I believe sort of building out the compute infrastructure in Europe is crucial for that. And the first topic really sort of points towards what Mario Draghi said in his report in the autumn. We have not built plus $100 billion or euro companies in Europe during the past 5 decades. That's actually wrong. Spotify is now above 100 since just a few months back. But we have one, while all plus 1 trillion companies in North America have been built during the past 5 decades. And I think this points towards the fact that, and I'm not the only one saying this, the fact that sort of technology companies and especially technology platforms will play a crucial role in future growth. Now, this is not exactly the same as building out compute infrastructure or building AI. But I do think that eventually all of these technology platforms and their value creation and the sort of flywheel that they've built is driven by AI at the core. And hence, eventually, I believe that it's just so crucial, first of all, to ensure that we in Europe are building technology companies and technology platforms, and then eventually AI at the core of them. Now, this is one angle. The other angle, because, I mean, you know, it's not realistic that we would be able to build in Europe a plus $1 trillion or euro company with sort of, say, efforts or actions that we can easily take. So I think, you know, it's a big question. How do we actually get there as Europe? But there are certain things we can impact. And I think one crucial thing that we can impact is related to some of the key ingredients for building technology. Compute is, of course, one, but talent is another key ingredient. And I think compute and talent go hand in hand. The most talented people want to work on the most ambitious projects. They want to work with the most talented people. And hence, I think it's just so important that we are providing the environment across Europe, but especially now in Finland, to be able to do world-class AI research, both in academia and also in industry. And in that way, sort of build out the capabilities, build out the sort of talent ecosystem, or more broadly, build out the ecosystem that allows us to attract and eventually retain that talent. And I personally, in so many ways, believe that this is where we can all impact. We can impact in sort of building those small initiatives that contribute into a vibrant ecosystem. And I've several times said that what they've done in Paris and France is a good example in building out, first of all, large R&D initiatives, building out a strong academic cluster, and now eventually you can see them also build out very strong AI startups. And then sort of the final point that I thought, I have the lead of AI Finland calling me, which is also a key contributor in the AI ecosystem in Finland. So there are many contributing to this. And I think Ellis Institute is one, AI Finland is one, and so many other initiatives that are driving the ecosystem. But eventually, I think it's just so important for Finland that we're attracting world-class R&D initiatives in the region, because that is one of the key ways to actually provide sort of the most challenging work for the most talented people. But then when we talk about AI, it's easy. I mean, now, of course, that is not the case, given that you've just heard AI being tackled from several different perspectives, not only language models, but that is still what most people believe AI is today. It's not true, right? There's tremendous innovation, has been for the past 7 decades, AI innovation happening in a wide range of different disciplines and use cases. And that is continuing, but that's also continuing in some of these larger AI workloads. And while we have now for the past 2 years seen large language models and chatbots and AI assistants create value, yes, we're now seeing the same happening with similar, actually, neural network architectures in a wide range of different disciplines. So, you know, that is what is happening in biopharma, life sciences more broadly, also on LUMI. That is what is happening in robotics. That is what is happening in visual media, entertainment, gaming. That is what is happening in software development and programming, and so forth. And I think, when we look into the future, which I think the LUMI AI Factory is aiming at, also given that it's not here yet, right, in the sense that we will have a more powerful supercomputer for the years to come, I think these are extremely important. And those are also segments where we actually have industrial companies in Europe that can drive this innovation, that have these technology platforms. And there I think LUMI and of course supercomputers overall can create tremendous value. But with that, I'll hand it back and I wish you good luck on the journey going forward.
Thank you, Peter. Do we have any questions for Peter at this moment?
Europe's competitiveness and growth solved.
Anyone? Oh, here we go.
Oh, sorry. Maybe
Go.
we'll go with the lady first.
Go, lady first. Yes.
Thank you for the great speech. My name is Satu Koskinen. I'm CIO of YGK, and we know each other. We have been doing the Poro project together. And I have the general level of question that we need the talented people and educated people is the most important that we can utilize AI in Finland. What is your tip or your medicine that we can get young people to interested in technical studies and AI studies? How do you see that? Or it can be also the little bit older one. For example, I'm doctoral studies doing concerning AI. What do you think? How we can get the young people to study AI?
That's a big question. And I think multifaceted in so many ways. I guess you're showing good example in, entering studies at the later stage. I think that's a reality. I was just asked the question, sort of how is the labor market going to sort of face this change? And it's not only change in demand for a certain type of talent, but it's also in the lack of demand for a certain type of talent. I've always believed in flexible labor markets that are able to adapt. And I also believe that this, while there is sort of a tremendous change and rapid change in one way happening, it's actually quite gradual. And I do believe that labor markets will be able to adapt to the sort of new needs on the labor market. I think that implies that people, first of all, not everyone needs to be an AI developer, actually, right? To create value going forward, you need to develop your skill sets to basically be able to contribute given AI tools. I think the reality is that not every company, actually a small minority of companies in Finland will be AI developers. Supercomputers create value still, but it's a tiny part of the labor force that should be developing AI. And then I think the key question for sort of Finland is how do we educate the rest of the labor force, well, the entire labor force, to make use of the best technologies and ensure that they create value on top of these AI-powered products and tools and so forth that we should be using. And then I think overall just that mathematics is extremely important as a curriculum in education. So I think we should focus on that.
Then we'll have one more question, and it was on this side, right? Yes.
So you built a remarkably successful tech startup in Europe, and it was an exemplar for what we'd like to see more of here. And then it was acquired by a near $1 trillion US tech company. What does that say about Europe's prospects to build leading technology companies?
I think a well-positioned question. It allows me to answer in many different ways. I think, Silo has always been a private AI lab. We continue to be a private AI lab. We've always created value in our sort of close vicinity. So companies across Europe. We continue to create even more value in Europe. So in that sense, I think, of course, being part of AMD provides a tremendous opportunity in creating even more value and working on even more challenging problems. And we're still headquartered here. We're still growing here. And in that sense, I do want to see that as an opportunity for Europe. And I think that there are many other aspects. I mean, the reality is that there aren't many strategics in Europe that are able to do sort of acquisitions similar to the acquisitions that are happening in North America. That contributes sort of to the ecosystem, and that has a significant impact on the ecosystem. I think acquisitions are a natural part of the ecosystem, and they should happen. And then eventually, I mean, we are very different to many of the other technology companies out there. I would want to see Europe grow technology platforms, scalable technology platforms that are not only, say, covering the North American market, but are also covering the European market. And I think my sort of concern today when it comes to Europe is whether we have actually a single market that allows companies to scale into that market so that they can raise a lot of capital, so that they can eventually sort of build something which is possibly not acquired at all, but eventually listed and grows into one of these plus 1 trillion companies. But this single market we do not have today.
Great. Thank you, Peter, for your thoughts. Okay, so now we move on to the next program. I would like to invite on stage Kimmo Koski, the Managing Director of CSC, to give a little bit of insight on how LUMI AI Factory is unlocking the potential for the Finnish and European ecosystem.
Okay, does this work? It should work. Yep. Hello. So it's a pleasure to be here. Really nice talks and nice discussions. So I try a little bit to wrap up or maybe elaborate a little bit about the impact of the Euro HPC, etc. So I'm warming up band for our minister, who is on her way from the parliament. So she will continue after me still. But anyway, so today we have seen number of welcome. And I start again. Yeah. Okay, Minister, members of Parliament, and ladies and gentlemen. So pleasure to be here. So today we have seen a number of presentations on how AI Factory concept works, concrete showcases, what can be done with this powerful new tool. And so the highlighted flagship use cases, they illustrate how transformative this new tool will be for the whole society and remind us how much there is still to explore in this field. So also they demonstrate how important it is to build and to boost our capabilities in Europe and how crucial it is to do it together. So now then, since EU is investing heavily on HPC capacity and AI, we are seeing a continuum that builds on existing infrastructure, work and collaborative efforts among European countries and partners. So the Euro HPC joint undertaking is a unique collaborative initiative, building the competencies and capabilities that Europe needs to be competitive and reduce dependencies. So through joining forces, we can strengthen our mutual trust and company in Europe, together helping our European researchers and companies to strive. Part of those things we have been hearing already today in the previous presentations as some good examples. So LUMI AI Factory, launched today, is a result of hard work, expertise, trust and collaboration among the Euro HPC countries, European Commission and our consortium partners, and of course our ministries also. So all together and together with other European HPC centers across Europe, we are creating a concrete solutions to boost seamless and fast access to our joint European capacities through hyperconnectivity and federation platforms that allow all Europe HPC facilities to be easy accessible for researchers and companies from anywhere in Europe. Well, I have been here quite some time also in the previous EU projects for the last, so 20 years ago I remember when we tried to put together, and we were able to put together a lot of European collaboration, but at that time EU didn't fund infrastructure, so there was not necessarily enough incentive to start sharing these capacities and investing together. And now with Euro HPC, actually this has changed, and we see the results. So, for example, LUMI is one of the first, and first time I think in European HPC history when 10 countries or 11 countries together and EU together invest in the joint infrastructure. So this kind of development is really crucial and important for the future. And now we have several, as you have seen, 13 AI factories, previous pre-exascale and petascale systems in Europe which can work together. So that will bring a lot of added value, I think, in the European competitiveness. So even the state-of-the-art technology is very much in focus. We shouldn't forget the importance of well-managed data, the critical raw material that we process with these machines. It's actually quite simple. That was also heard today before, that if you put a good quality data in, you get good quality results out. Okay, so that's one, and vice versa also. So if we are thinking about the competitiveness between different continents, how Europe can succeed, one of the ways we can succeed, we have a good data and we have excellent people. So these are the two tools where we will be able to close the gap with the other continents if we, and when we are doing some competition also here. So in addition, as I mentioned, we need to have people who have the combined understanding of HPC, high-performance computing, and discipline-specific challenges that are being solved. So this has always been the core of CSC's service concept, because of the impact doesn't only come from the hardware itself, but when we combine it with data and people, we start to create value. Okay, so we have applied this approach also to LUMI AI Factory, and it's truly pioneering AI solutions, seamlessly integrating world-class computing power, high-value data, and a top-tier AI talent. So the AI Factory will unlock data with the datasets as a service, spearheading access and enable groundbreaking use of the high-value datasets, such as the European Open Web Index, also mentioned already today, and produced by the Open Web Search.eu project, spatial data, speech data, etc., etc. So I would like to underline the importance of these powerful infrastructures as tools to create a new talent across the society. And so AI will certainly take away some jobs, some types of jobs, and what eventually replace them is yet unpredictable. But what we can see already now is that high-performance computing, AI, and data are fundamentally transforming research and businesses, and even the way public institutions work. So I believe that we will not run out of the jobs, but new types of professions and jobs are created through technological development. So the world will need so much more understanding of development, application, implications of this transformation, not only in technical fields, but in all fields of business, research, and society. So the need for combining skills and expertise from different fields is an enormous challenge and extremely big opportunity. So the current LUMI supercomputer is already now one of the world's most powerful AI platforms for science. So nearly 3,000 research projects have been run on LUMI, with over half incorporating AI already. So the current LUMI is already an AI platform, driving research excellence and industrial RDI across Europe. There is also quite a lot of industrial use in the current LUMI, so which is also very, very good. So when the current LUMI supercomputer's life cycle comes to the end, it will gradually be replaced by a new AI-focused supercomputer called LUMI AI, which is today launched. But the project AI Factory is today launched. I mean, these two machines, the current LUMI and the future LUMI, they will work in parallel for quite some time in order to make a transition very smooth for the researchers. So that, I think that is a very important point also here. So the LUMI AI Factory will act as a state-of-the-art expert support center and hub offering European companies and research an inclusive and comprehensive innovation environment. So this one, so it's not only computer power, it's also human power or human expertise to support that. And this you already heard earlier in the previous presentations. But that is of course an extremely important thing that which makes this system and the ecosystem work and work and usable for research and industry. So it's a joint platform accelerator for RDI activities by companies, research groups, and public actors. Okay, so we are expecting a high social impact and return on investment, and we'll be measuring it. So far we have found that the social return on investment of the CSC's high-performance computing services, including LUMI and also the national systems, by the way, is high. So according to a study made by an independent research agency, Taloustutkimus in 2023, €1 invested in HPC services brought back 25 to 37 euros as direct economical impact in multiple ways. So that's what we are aiming at. So, and in addition to HPC, quantum computing is one of the Finland's strengths. Therefore, I'm extremely happy to share that the LUMI AI computing environment will be complemented by an experimental quantum computing platform, LUMI IQ, designed for workloads combining quantum computing and artificial intelligence. That's one of the kind platform will open completely new horizons for research. LUMI AI and LUMI IQ will form the most advanced public quantum accelerated HPC and AI research infrastructure in the world. So Finland is already one of the world's most advanced countries in this respect, as LUMI supercomputer was linked with VTT's Helmi quantum computer already in 2022, enabling hybrid computing project and boosting the development of quantum algorithms and software. So, and LUMI AI Factory will be located in CSC data center in Kajaani, next to LUMI supercomputer and our national supercomputers. So the data center is one of the world's most energy efficient and climate-friendly data centers, as we heard already before, which is excellent free cooling and usage of waste heat to heat houses in the region. So fortunately, it's cold enough here in Finland, so we can use the waste heat. It's very useful here. So we are proud to be able to help to reduce the growing climate footprint of digitalization. So finally, I would like to come back to the notion of collaboration. So the LUMI consortium is a unique joint endeavor of 11 countries, the current LUMI consortium, I mean, with whom we have been able to, and EU, with whom we have been able to provide more impact than we could have done alone. So together with our LUMI AI Factory consortium partners, Czech Republic, Denmark, Estonia, Norway and Poland, and EU joint undertaking, and our national partners, FKI Finnish Center for AI, Aalto University, Helsinki University, and AI Finland, we will continue the success story, and through EuroHPC we will work together with the European Union and EuroHPC participating countries to build a stronger Europe. So the AI Factory, LUMI AI Factory, other AI factories, we work together and make it happen. So also we are happy to be a part of the collaborative data center ecosystem in Kajaani, and we highly appreciate the support we have got from this region, which has been really great also. So last but not least, seamless collaboration with our customers and users, the ones who actually create the impact, is absolutely critical for us. So I would like to warmly thank all of our stakeholders and partners, funders, customers, and of course my colleagues at CSC for making this happen and joining us on this exciting journey. Thank you very much. And next, I would like to give the floor to Finnish Minister of Science and Culture, Mari-Leena Talvitie, please.
Thank you, dear audience, ladies and gentlemen. I just heard that I'm between you and cocktails. Maybe that is the reason I would say that it's really great pleasure for me to speak at this launch event of the LUMI AI Factory. LUMI AI is an important new opening for the city of Kajaani in the north and for whole Finland. Our government as well as CSC have done significant work making this possible. Supercomputing is great strength for us. It makes us more competitive international as well. LUMI AI makes scientific breakthroughs of the next generation possible. It encourages new research cooperations as well as growth and new innovations for companies. With LUMI AI Finland will be a forerunner in the global context. For such a small country like us, it's really something to be proud of. LUMI AI Factory is a major investment for Europe and for Finland. Our government made a significant commitment as we decided to aim for upgrading the current LUMI supercomputer. In December, we got the best news possible. EU funding will be over 300 million euros, and on top of the Finland alone will provide 250 million euros. The other consortium countries will provide 50 million euros. It is needless to say that this is a major financial commitment to us. We are deeply thankful for the support of our partners within the consortium as well as Europe HPC. Dear audience, supercomputers are vital, but alone they are not sufficient to make top science and research possible. There must be expertise to apply these computing researches effectively. Skilled people with vision are the research that we need. Education, training, and user support are their essential services. The LUMI AI Factory will bring these services to a new level and they were increasing the possibilities for both scientific and applied research. It's encouraging to see that also researchers from social sciences and humanities are increasingly using computational methods in their research. For example, language studies benefit from artificial intelligence and computation methods, enabling new knowledge and applications. CSC's data center is located in Kajaani, in a former paper mill. This provides an excellent operating environment for the LUMI AI Factory. The data center is also a forerunner in environmental friendliness, with hydropower as a renewable energy source. Additionally, the waste heat is used to heat the local houses in Kajaani. That is something very Finnish. We know how to be resourceful and how we can make things work sustainable in the harsh Nordic climate. Kajaani is also attracting private companies with their data centers. And the XTX Markets company from UK and a Borealis data center from Iceland are already building their data centers activities in Kajaani. More recently, Google has acquired land in Kajaani and Muhos for a future data center. I'm certain that these decisions were based on the excellent operating environment in Kainuu, which included availability of ecological electricity, data network connections, and synergies with CSC's data center. Ladies and gentlemen, I would also like to emphasize the importance of talents, and especially those with the highest level of education, that is, doctoral and master's degrees. The government has recently invested for the doctoral degree pilot. In total, 260 million euros have been allocated to 15 doctoral pilots in different scientific fields. The aim is to train in total 1,000 new PhDs and to increase the mobility of doctoral graduates between universities, research institutes, and companies. The doctoral pilot for AI has been extremely attractive. There were more than 3,000 applicants for the 100 study places in the doctoral pilot. Many applications came from outside Europe. which shows the attractiveness of Finland as a place for scientific research and education in AI. I'm certain that access to world-class scientific computing is one of the reasons for the success. Another important new initiative is the ELLIS Institute in Finland. This institute is a part of the European Laboratory for Learning and Intelligent System. It will create in Finland a world-class research and innovation ecosystem with top talents in AI and machine learning. Ladies and gentlemen, I can't emphasize enough how great it feels to be here tonight after one plenary sessions. LUMI AI is a milestone, a great success for Finland. Let's embrace it and celebrate we made it together. I wish the LUMI AI Factory all the best success. Thank you.
Thank you, Minister. Thank you, Kimmo. So, yes, I'm just to do so. So, in a bit, we can go and for the networking event. But before that, I will introduce you to the the virtual posters and the demos. Yeah. Okay. So this one. So on the lobby over there. So feel free to stop by on those stands there. So there's, for instance, well, Alex will be there to sort of like discuss further on anything was already presented on the AI Factory service portfolio. Then we have a very interesting way of doing science. This we call citizen science. It is this kind of like a very popular way for collecting biodiversity data by making people to record the bird songs. So every time you hear a bird, you basically take a recording with your phone, and the ecology researchers have collected a very big data set of basically the bird. How birds migrate on the spring. So there's the how to do this. How this was done it will be presented. Then I'm not sure if we have. I think we don't have the climate information. The Klima site bot there, as Jarmo cannot be here, but I don't know if we can something come up on the fly with Irina or somebody to showcase that one. But so let's see if we do have the demo or not. Then we have the model serving platform of LUMI called Aita. It's just about it's kind of a beta stage. So how do one can deploy AI services and this kind of like a AI as a service on top of the LUMI resources. And then how does LUMI look like for our AI users? So how does using a supercomputer look like? So there's just like a demo of doing artificial intelligence on LUMI. It's one of the posters. And then we have a stand for the ELLIS Institute and the Finnish Center for AI. And then we have this kind of like a posters for our industry cases. But I think this kind of like a conclude. So let's go there and have a further chat. So many thanks again for everybody for coming. Everybody online followed, and like I said, thank you.